Hello, good morning. Thanks for joining me in my shop. So today's goal is going to be to make those key adjustments in the output of this CB radio that I believe I've got all my equipment all set up for. So that should be pretty interesting. The goal will be to get the most power out of the back of this thing without setting it up so something is overloaded in the radio, which is basically what the instructions read anyway. But first I wanted to show you some cards I received over the years. You can see them right here. Take a close look. I'm just going to flip through these quickly. So these are QSL cards. I got these back just after the year 2000. It's fairly active on ham radio. I was using PSK 31, a digital mode which was new at the time. Other modes have kind of taken over now in popularity. It's a Jamboree on the Air, so that's a scout event. Scout and Girl Guides. And no shortage of design on this one. Mr. Print Limited. Bradford, Ontario. There's the guy's radio right there. You can see the frequency I was on, 14.070, and that was 4th of January 2003. Another Jamboree on the Air. I was a scout leader. And now, the best card of them all. That's my card from when I was in high school. I lived in a town called Beamsville. And this was my card that I handed out. I still have 20 or 30 of them. And now, for those of you who have watched so many of my videos and generally all you see of me is my hands, my shoulder, my arm, here's a couple pictures from when I was working. Yeah, that's me there. And that's my crew in this van. I'm their supervisor, and they're going down into a electrical manhole in Toronto. And I'm there for reasons I can't remember, of course. I have this picture. That's me in my office, in the head office of Toronto Hydro. A little out of focus, eh? When I was busy. These are all my corrosion certificates up here. I was a corrosion technician and many other things. And that's just an old picture of the city there, but you really can't make it out. Anyway, so that's just a little bit about me in the past. I don't mean to bore you with that kind of stuff. Let's get back to looking at my hands and my shoulder and this radio. I think the smartest thing I can do before I really get going on here is review the instructions clearly, make sure that's really fresh in my head, and then we'll get on with actually testing it. I have the set on. It's just been on for quite a while, just making sure it's fully warmed up and helping me in my shop. It's another cold day here in Ontario and much of Canada. It's extremely cold. It's about minus 19 outside, I think. So I'm going to read that manual, then we'll get going. Okay, so I read over the manual again. So there is a bit of a challenge here. I'm not too sure what to do about it, and that is when I'm making the next adjustment, I have to monitor carefully the plate current in the output tube, which the manual says should be 22 milliamps or less. The tube information I got for the particular tube involved suggests something quite different, 26 milliamps minimum, and as much as, say, 30-35. Quite different from 22. So that little concern there, but that's okay. I will follow the manual, and the people who designed this radio must have knew what they were doing, I'm sure of that. So we'll aim for 22, but the challenge is it's 22 milliamps measured across a 100 ohm resistor. That yields a very, very small voltage, something like 220 nanovolts, something very small anyway. It's very, very small voltages, very, very tricky to measure properly. So I think what I'm going to do at this point, I have the radio operating here. We have the meters all hooked up, so I'm going to turn it on. We're going to hit the mic. I'm going to look at what that meter says and then see if this jives with everything I've been up to here. everything I've been reading, rather. So I'm on the volt scale. There is a millivolt scale on this meter, so we're probably going to end up on that. So everybody watch. I hit the switch, always bearing in mind I'm holding a big metal electrode in my hand when I use this radio. Here we go. Well, that's a hugely different reading from what I was calculating. What am I doing wrong? So I'm going to stop for a while now and consider what I'm doing wrong. 1.8 across a 100 ohm resistor. I'm doing something wrong, for sure. Okay, I'll just turn the radio down a bit here. So if we look at the schematic, I'm concerned about something. And that was the RF choke in the voltmeter lead. Was there one required? Here's the 100 ohm resistor I'm reading across. And there's note 2. Note 2 is about taking a resistance reading here. It's related to this reading, this 89K. Nothing to do with R6. There's no notes around here saying anything about protecting the voltmeter here. And in fact, we have this choke coil right here, choking out or blocking, maybe it's a better word, any of the RF. And any RF would shoot down to ground here. There should be no RF problem here. There should be straight DC, in fact, nothing more than the DC. Now, you know, I have another, it's not a good option, I have another option to read it down here. The problem being that the current in this resistor is 7 watt. It's one of those big 7 watt resistor that includes the this current, which is going to be substantial. So I'm stuck reading some millivolt reading across here. I just can't see how to get around it. I hate to admit it, but my father was a high school math teacher. Can you believe it? And I can't even divide two numbers here. So the way this is working with the 100 ohm resistor in there, if you push 22 milliamps through the 100 ohm resistor, you'll get a reading of 2.2 volts over here. So we're getting 1.8 volts, that's 18 milliamps. So we're below the 22 limit at 18, and I can practically read this directly now. Instead of 1.8, I really read it as 18. Okay, so now I know I can monitor the output tube current while I make these adjustments. And what are the adjustments? So the adjustments are twofold. One is a capacitor. I'm just checking the tool here. I think I'm better off with a screwdriver on that. Just a bigger handle. This was quite sensitive. Same screwdriver can do the other one. Now it says make the adjustment, check something. If it's not right, then make more adjustments. Actually, that's coming in the next step. So this is quite a iterative process. So let's start here. The first step: adjust L9 for a dip in the plate current. In other words, adjust L9 for a dip. Okay, I can do that. So what it's saying is this voltage should go down or be down. It could very well be properly adjusted right now. So again, bearing in mind I'm holding an electrode here. Okay, we all set for a dip. Looking for a dip now. Okay, 1.8. Oh, you know, I should be using an indicating meter on this. I can't do it with a digital meter. Cannot do it with a digital meter. So, you know what? I'm just gonna switch over, I think, to which one. I'm looking at what's visible in the camera here. Let's give it a go with this one here. Just move cameras around and stuff. Okay, let me get this set up. It's going to take a moment to get this thing set up and working right. Okay, I started setting it up and right away decided, wait a minute. I'm a little worried about taking a meter of this sort, which is plug in the wall, 2-prong meter, and hooking it up so the negative lead isn't grounded to the chassis. Instead, it's in the circuit somewhere. Both leads are in the circuit. That's why I picked this meter in the first place, because it's isolated and completely. It's just a digital handheld meter, right? So we're going to have to put up with the we'll have to put up with the display. I think there is a bar that moves on it, but okay, enough of that. Here we go again. I would really much rather have a indicating meter there. I wish I had an old one like that, but I don't. Here we go. Okay. Now, 1.89, I turn it this way. So went up. Turn it back this way. It went up. It keeps going up. Up. Let's go the other way. It's going up. It just keeps going up. What is happening? Oh my gosh, this is a I never actually held it on for a while to see what would happen. The voltage is drifting on its own. Let's try it again. I'm just going to turn it on and hold it here. Definitely into the dummy. Okay. 196. There it goes. Here's something else I noticed. The resistor I'm reading across appears to have been overheated, even though we checked the resistance of it earlier. I think it measured 99 point something, right, just about dead on. But it doesn't look very good when you look at it down in here. I wonder if its resistance is changing on load. It's heating up a little bit and changing. Give you the give you a rising reading, while in fact it's actually reducing the current. I don't think I can do this like this. Wow, inserting an ammeter right into the line. Wow, I don't like that idea either. I'm stuck here. I'm really stuck. I've got two problems. One is trying to make an adjustment looking at digital numbers flashing. That's really bad. The other one is it's not stable in the first place because it just seems to drift. Oh man, I don't know what to do. Try when I move. Let's push the button. How far will it go? It's so steady. Just keep it like this till smoke comes out. Oh, I think it's slowed down there? No, it's just the way it's counting on that digital. Well, I don't know what to think. I'll show you the capacitor. Let's look at the resistor together. We'll see what. Remember, Jim, the radio is on. This camera I'm holding is actually grounded. I have found out a couple times by unintentionally. Can't see if it'll focus. Son of a gun. Okay, let me just manually take over the focus since it's not now it wants to focus. You uncooperative camera, you. I'm going to put it on manual. Zoom it in just a little closer. Okay. So we're looking now. Or am I clipped wrong? Good question. So this doesn't look right. So the resistor I'm after is it's really hard to see. Again, just I don't want to short this out. It's that dirty one there. Now you can see it. That thing. That thing that looks... like, why does it look so bad in there? Protected away under stuff. Because it got hot and soft. It got soft, so you can clearly see one lead is on one side of it. And now the other lead is this one here. Doesn't seem right at all. Okay, what's hooked up to what here? Okay, hold on a minute. I got this lead in here. The clip lead's not connected to anything. What the heck was that doing there? Must have been doing something earlier. Okay, one lead out, a little simpler now. Look at the two clip leads. Is that really around that resistor? So I think it is. I think so clearly that's on one end. No question. I mean, what would the chances be that I would hook this up wrong and get the right kind of readings off it? It's next to nothing. And just there's the other end of that resistor. Yeah. Almost got a short in there between those clip leads, eh? They're definitely on the right thing. Wow. Resistor looks rough, but tested correct. Tested okay. How would I know? You know what I could do? What I can do is I can run the heat up. Well, I can transmit for a while, watch the voltage go up, shut the set off, take a resistance reading right away. That's tricky, man. There could be lots of DC voltage left in capacitors and stuff that would be coming out initially. Let's try it. I'm going to try it. Okay, so raise it up, turn it off, switch to ohms. Okay, I'm ready. We'll let it go up quite a bit. It's like I'm sitting here waiting for something to explode. Okay, I think that's good enough. Okay, off with the power. There's no voltage remaining. The ohmage says exactly the same, 99. Oh, it's dropping. Wait a minute, is it? 99.4. No, it's not dropping. It's 99.49 or something like that. Or is it dropping? I wouldn't say so. This is the same reading I got before. Let's back up to 5. So no, this resistor is absolutely stable. So the slow increase in current flow has to be due to something like, if I had to take a wild guess, leaky capacitor protecting the grid of the tube from a positive voltage. If I had to guess, that's what I would guess. Oh my gosh, I wasn't expecting this. What else is new? Let's look at this schematic and see if we can't identify some capacitor that might be responsible for something. Luckily, there's a lot of capacitors in here, so... Okay, here we go. The area we are concerned about now would be where this 100 ohm... Okay, so the 100 ohm is right here. This is the tube that appears to be unstable in its operation. There's the grid. Oh, I remember reading an incorrect grid voltage on here. Let's zoom in. Isn't that true? That's right. It's supposed to be minus 1.7, but the grid voltage was way off here when I measured it. Way low. It's like minus or something like that. Clearly, here's a capacitor that could affect it, could leak the positive pressure from here, push its way through a little bit, charge this up. This weighs a 10K resistor. That's not terribly big. The ground, and what's going on up here? Oh, we have a choke coil, and then a capacitor. So it's just trying to filter out any RF that might sneak past here, sneak past this coil. Where else? Let's go a little further. Keep your eye on this. Oops, can't keep your eye on it. Where to go? Jump way the heck down here. So there it is, right here. Go along. Another capacitor to ground. 0.01. Yeah, 22. We're up into the mixer. We're way out of our lane. Well, what's this guy doing here? This is just finding a ground connection here. That's all that's doing. It's affecting this. But again, in terms of making this voltage incorrect, looks like this capacitor would be the guy. This capacitor here, C40. C40 off of pin 3 of the 7061. Let's go find it. Because look, the pressure on this side is 330 volts. That's a lot of pressure for a little capacitor. He's probably just giving it up. Let's check him out. C40, gotta find him. Oh, wait a minute, we can look for him first. Look for him here. Yeah, this is a smart move. So C40 is gonna be right around the trouble guy, I think. C40. 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 Hey. There's no C40. What have they done with C40? Oh, I hate looking for things that maybe aren't even here. I've been looking at this for a long time. Convincing myself it's not here, but I should double check anyway. No, I don't see a C40. Is there some wild chance it's up on top? Can't be on top, can it? C33. Look what it is. C40. Can't. C44. Well, that's a adjustable. So I'm looking for a C40, which is just a capacitor. That's certainly not here. So I'll have to do it by going from the grid here. Whoops, where? Grid. The grid here, pin 3, and look back for this capacitor. It's probably easy to find. Okay, let's do that. Can't do this with a close-up camera. So so this is the 70612 tube right here. Let me just get focused. Pin 3 would be okay, good thing the set is off. The set is off right now. Pin 3. Can we read the numbers? Yes. 7, 6, 5, 4, and 3. Just would like to see the number 3. There's 4, so there's 3. So 3, it's kind of like, this is a really clunky way of doing this. So I think that's 3 right there. And I see an awful lot of stuff hooked up to it. Wait a minute, is that grounded? I don't think that's 3. So there's the hole. So we count. Don't be fooled. There's the number 1 pin has nothing soldered on it. It's very hard to see. I'm having a heck of a time seeing my own TV here. Just a second. Okay, I can see a lot better now. Oh, jeez. Scare the heck out of me, Peanut. Man alive. Woke up this morning at 2 cats on our bed. Actually, 1 cat on our bed. The other one was right under the covers with my wife and I in between us. Picking gently at my toes. Yes, Peanut. I can hear you, man. You sound like you're close to death. What is it? Oh my gosh. You know, I'm getting nowhere here with this. Let's play with the cat. No? Yeah, I'm going to go play with the cat for a while. We'll come back and figure out this pin 3 thing. Oh my gosh. Okay, so we're looking at the schematic here. This is the grid I think has gone, well, I know it's being pushed 1.7. Right. Okay, so when I measured this before, I just got stunned because this number is almost the same as what I'm measuring across this other resistor over here. It just confused me a little bit. Okay, so when I measured this, not 1.7, but something like 0.2, something like that, 0.3, and so it says this is the capacitor I'm curious about. If I look at this point here, this part of it, I see coming from the grid, I see 1 resistor, 1 capacitor, and 1 inductor. So the point I'm looking for should have these 3 things attached to it. Let's go back, look at the radio now. So we're looking now at a close-up of the 70612, and we're looking at pins 1, 2, 3. So a little tricky for me to point here. This is 3 here. This one right here. This is the coil. Do it with my own eyes. This is the capacitor. This is the one I think might be leaking, and then there's the resistor back there, all connected to this pin here. Oh yeah, I was just about to show you something. That's right. Okay, so see the yellow capacitor right in the middle of the screen. See the lead? The lead is soldered to this metal plate here. Look at how long it is. There's no lead. Look what they've done. They've eliminated one of the leads on that capacitor. So when I see things like that, that tells me, you know, there's a lot of fiddly little stuff. This is a 27 megahertz machine. And if I were, well, it looks like a burn mark on the end of that coil. Doubt it, no. So if I get in here and fiddle around and start moving parts a little wee bit, I might have some very undesirable effects. This thing, we're all packed in there. See, for all I know, these components are on angles that are critical. You know, and right angles to other circuits to avoid interference. I don't know. Even the guys who made this don't know. They just know if they build it exactly like this, it works really well. So don't build it any differently. Oh man, how am I going to do this? Well, there's really only one way to do it, and that's to do it. Okay, so plotting out my crime here. Oh man, I can't even get cutters down in there, can I? See, I'd be tempted to relocate this capacitor up into a different position. That'd be a lot easier than what I'm about to try. But if I do that, I think I'm gambling. Big time. With a result that I may not understand or recognize the effect of the mistake I've made. I may go off on some wild goose chase down the road, once again chasing one of my own mistakes. I get a soldering iron in there. Is that really a tent? I can't see the numbers on it. I sit and stare at it all day. Yeah. I wonder if I can fish the new one in there parallel to the old one before cutting out the old one. Why would I even bother? The moment I cut that old one, it's got to come out. Okay, enough lamenting. I'm just going to go ahead and do it here. Okay, here we go. Now, okay. I make room for my cutters to get in there. Well, I cut something. Something got cut. There it is. I don't know if I did that or if there's some crack on it here or something. Let's take a little closer look at that. I doubt there's a crack. Let's look. I think that's more along the lines of just a mark on the outside of it here. Definitely a 10. I'm looking where the leads come out of the package there. Like I said, it wouldn't take too much of a leak to cause a problem. Okay, that doesn't look that bad, but it looks exactly what I kind of expected. Now, can I possibly do this? Yeah, I think so. Can't let one capacitor stand in the way here. So first we need to size it. Decide which terminal to get on first. I think I'm going to go on this. I'm going to do the deeper, more difficult one first, because I can bend the capacitor kind of out of the way while I'm doing that. Once you hook it up to the other terminal, there's not a lot of options there. Now, what about getting the soldering iron in there? My oh so messy bench. Holy smokes! I gotta really take some time. Okay, so it would go in like this. It's not hot. The soldering iron's not. I go in like that. That would work good. The other one's not really a problem. It's this one down here. Yeah, that's got lots of clearance there for the soldering iron. Okay. Feeling a little better. Now, let me just double check the capacity of the capacitor I'm about to install. I'm going to do a lot of effort here. These are almost always bang on. .001. Oh, I missed the hole. That's better. 10, 11. 10 or 11. Take your choice. 10. I'll take 10. We'll save the extra one for later. Okay, now we want to make the leads, of course, as short as we can get away with. So I want to kind of get it on there with excess and then trim the excess after, because you cannot cut it shorter. Once you've done it, you've done it. Okay. This lead's going to be in the way too as I put it down there. I have to cut the other one or bend it up. I don't want to bend it too much. Bend it up and bend it down again later. So I should cut it to its necessary length. Holy smokes. Let's cut a bulk of it off anyway. assume that this is going to be up this way. Bend this lead up roughly where it's going anyhow. Ooh, that's a lousy pair of pliers. Don't use those normally. Don't bend anything. Don't move anything. Don't drop anything. Going in this way. So I go down and around. Maybe something like this. Gonna go down and around. So well. I do want it to go in like this. Like that. It's more of a grip. Bend this up a bit. I got that in pretty good position here. See it there? I sure don't. Don't fall down now. Ah, I'm losing it. Pretty much just got to kind of solder it in and then, wow. So think of all these steps, you know, like I'm just doing one in the middle here, but look, to build this whole thing, you've got to put in these hundreds of parts. There's got to be a rational order to doing it, like a better way and a good way and a bad way. Look what's happened here. I've totally lost my plan. So part of engineering anything is engineering the building of it. You can't just engineer the final design and then hope somebody can put it together that way. You actually have to. I bet you that's one of the weakest parts of the whole process. This is just not happening here. The way I've got this. Just keep going a little further with it. Got a lot more lead on it than the original. Pair of pliers, not the grippiest ones either. Just fall in place. Oh, don't go into there. Yeah, you're worse than a cat. Any cats hear me say that? Hope not. One more time, here we go. Going in. Oh my gosh, I almost got it. You know what? I almost got it perfectly there, except, come on out. Except the gap was too small. Here we go again. Around that wire. There, oh! Now I gotta get ready to squeeze it closed. Another pair of pliers here I don't use very often. Okay, grab it. Oh, darn laughing at myself. can't believe it. I got it right in the right spot right now. Okay, let's see if we can't squeeze it down. Maybe I should tack solder it right away. Okay, get on it to squeeze it. You know what? I got it. Let me take a close look at that. See what we ended up with. What did we end up with? What did we end up with? Well, it's a little out of focus, but I think it's right on the money there. Where'd it go? Looks good. It's the right spot in everything. Okay, let's try soldering that in. First I'll clear up the vision. Okay, soldering iron. And solder. Hey, where's the soldering iron? What's happening? Soldering iron's on fire. Oh, it's right here. Oh, son of a gun. I left it laying right on my bench. I've never done that before. Wow, that's really a bad move. You know what? That's an outcome of having a messed up bench. My bench is just a terrible mess here. I really need to fix that. I'll fix that later today. Okay, going in for the kill now. First to practice. Solder. Quite. Gotta kind of bring the soldering iron in on an angle like this. Solder in there. Okay, I think I got it. Now, switch cameras. I think I had to do. No, did I solder a bunch of stuff while I was doing that? Okay, going in. Solder going in. There we are. We're doing it. Solder up. Come on. Okay. Okay, how did we do on that? I can always go back later. Oh, no wonder I'm having camera trouble here. It's tricky with these little webcams, you know, they can be knocked over just by the cord getting tugged on, or just move the cord. The cord's laying all over the place. What a weird looking view that is. Yeah, I think it's nothing more than, yeah, optical illusions I am seeing. Now we gotta get the other wire hooked up. We're going to take a close look at the first one. Let's not. Whatever it is for now. Get the other wire hooked up. The other wire has... Where's it gone? It's gone. It's managed to wrap itself. Is that the right... That may be the right terminal it's wrapped around already. Oh, well, hey, look what the... Oh, this is the close-up. Okay, starting to mutter, Jim. Because the pressure is on. Pressure is on. Now, is that other capacitor lead in the right spot? So I left a little tail somewhere in there. There, okay, great. It comes up to, oh, there's two of these guys. This is the one. This, I follow this lead down. That's where the capacitor should connect. So it's kind of, yeah, it's close. Okay, I see what's going on. I see it. I see it. Still see it. Can I get in there and grab that? I hope this helps. Hopefully this will stop the, this will correct that voltage on the grid, which will correct the current flowing through the tube. Let's think about this. What did I read? Did I read high or low current? I read low current, 18 instead of 22. And it was going up. Okay, so if you decrease the grid voltage, then yeah, plate current goes up. Did I get that? I'm trying to see this with my own eyes. Looks pretty good. My eyes. Okay, any short circuits happening in there? Where? Oh my gosh. Not sure what I'm seeing there. Let's go full close up here. Zoom in. Radio is switched off, of course. Okay, now we're really trying to get a close up here. There's a wire going around. Oh, it looks great. Looks great. Pinch it ever so slightly. I could pinch it a wee bit more, especially if I come in the same angle as the camera. Okay, let's try that. Same angle as the camera. I think I said it was minus 19. This was minus 20. A little bit colder than. Where'd it go? Okay. Well, that's all we're gonna get there. Okay, let's solder that. Let's solder that. Can you imagine if this thing was full of paper capacitors? I mean, how could it be? It would be 3 times the size. But if it was, how many of these you'd have to do? Oh my God. It would not be possible, I don't think. Soldering iron. Oh, don't knock the antenna over. Too much stuff here. Temperature down a little bit. Just up a little high there. Okay. Coming in. Get down on my knees here to do this. Getting solder on things. There. I can't see now, it's too dark. Wow, no idea what I did in there. I'm 3 feet away from it. I'm trying to see what I'm doing in there. Okay, Let's see what damage I did. Did I get it? Wow, doesn't look good. Looks like I missed it entirely. Looks like the lead is too far away from the terminal. Let me wiggle the capacitor here. Did I get a bite at all? Yeah, it did get soldered. Can I improve on that? Let's see the side here. I'm sure I can improve on that. We just have to get a little lower down and get right on the lead itself. I think the capacitor lead may not have heated up. Okay. That's the prognosis. Insufficient heat on the capacitor lead. Okay. Now we're going to try again. I'm 3 feet away from my head is 3 feet away. I'm at arm's length trying to do this. Way down there. Well, I'm heating the lead itself now. That's not quite the best idea. Sorry about the camera shots, but I can't deal with it all. I can't deal with it all. Okay, let's try that. I can't quite see what's happening. More solder. Oh, I think something just jumped. The old lead just popped off, I think. Oh, what happened here? Okay, let's see what happened. Close-up look. Yeah, that looks pretty good. There's that lead. It's not going anywhere. Oh. Looks a lot better. Let me try and wiggle it. It's rock solid. Okay, the other end, which I kind of didn't really solder it maybe as well as it could be. Well, it looks pretty good too. Yeah, I got it. By Jove, I got it. Okay, we're ready. Ready now to retest the radio and see if this did anything. Or did I break the radio? Okay. Up here again. Anything else I need to think about before so these clip leads are still where they should be. Certainly appear to be. That's the voltmeter. Turn it on. Voltmeter in volts. So we're looking for 2.2 on here. 2.2 in the negative direction. Is that right? I don't know what direction. 2.2 anyway. Okay, I think we're set. Just something else not right here. We don't have anything on the output. Hey, don't do that. We don't want that. I have to key this. Alright, I undone this. Very short lead here, doesn't give you many options. Okay, we got that. Scope doesn't matter. Meter, don't think we're paying attention to that one. One all looks good. Okay, power on. Did it with the dim bulbs because I made a change. Everything looks okay. Watching that voltmeter. Isn't that voltmeter supposed to show something? Even now? What happened? Ooh, how do you like that? I don't. Never noticed that before. No, that's not. Maybe not. Maybe that's not supposed to show anything. Let's hit the mic. Hit the button. We're on here. We're switched to dummy load. We're backing up. We're standing back. Here we go. It's 1.1. Wow. Okay, something. Okay, so we're still on partial power here. Let's fix that up. There we are. 2. Okay, so we're aiming for 22. Okay, so does it drift? Still drifting. But I got a different voltage. So it's drifting, it's drifting up in millivolts. It's drifting up in millivolts. The big number, 2.0, that's not changing particularly. 22 milliamps means there's more current. This thing should be reading 2.2. 2.20 something. That doesn't matter. Now I think we're okay. We'll forget about the drift upwards for now. Did that capacitor changing it have an effect? Seems to have had an effect. It didn't stop the drift. That bodes very poorly for all the rest of the capacitors that might be in there. I could potentially test this. Maybe I'll test it later for leak. Okay, so now we're ready to actually do the thing. Let's do the thing. So the thing is adjusting a capacitor and a coil. First the coil to create a dip. Let's try that. And then well, not to create a dip, but to make sure it's in the dip. Okay, ready? Again, watching that meter. Just going down, down, down. Down. Wonder what the duty cycle is on that. Up. I don't see any dip. Of course, you know what? Of course, I'm transmitting all that. So if my neighbor's listening with his CB radio, he's hearing me talk away as I adjust this one. No dip. No dip. Son of a gun. I want my dip. Somebody give me my dip. Let's read the manual again very carefully. Adjust the Pi-L output network for maximum power output while keeping PA plate current at 22. So I shouldn't be watching the plate current or less, whichever gives the most output. I was looking at the wrong thing. I should have been looking at the power out. while I was doing that. And just keeping an eye on the 22. Save time, make a rough adjustment. That's what I'm trying to do. And after we neutralize, you go back and make a final adjustment. Simultaneous adjustment of the plate tuning L9 and PA plate couplings. Simultaneous tuning. Okay. So let's try this again. This time we'll watch the power output and see where we go here. What's this thing? Adjust L9 for a dip in plate current. Adjust C49 for the desired PA plate current at the dip. Coupling will increase as the capacity is decreased. Make the last adjustment that of tuning L9 for a dip. Usually the dip is very sharp. That's what I basically imagined here. It would be a sharp thing. Okay, let's check it out. Right, we're going to watch the power here. We're supposed to watch for a dip in the plate current. I don't like it. I don't like what's happening here. This is not working out at all. Okay, trying to keep my eyes on too many things at once. There we go. I'm watching the power one now. It's going up. Going down. Going down. Maximum rate in this area here. And the current's well under the 22. Now we're supposed to adjust this. I don't like it. I don't like what's going on here. It's not performing. It's supposed to see a dip, adjust the capacitor. Let's fiddle around with this. Here we go. This was really sensitive, if I remember right. Watching the power. Down. Oh. Okay. Adjust this other one for a dip now. A dip in the plate current. Okay, watching plate current. Voltmeter. It's going up on its own. I think I'm driving it upwards. No dip coming. Oops. Like I say, I think it's a sharp dip, but maybe not. It's going back up. That problem is it's going up on its own. Holding it. Back up. So I think the dip spot is right in here. But wow, that's not much. You can't even call that a dip. That's like a low point. So either that's adjusted way off. Kicking out all of 2 watts at this point. Two watts on here. Power. Dip. I'm watching the power too. See maximum power. You can see that power meter going up and down. So regardless, I can see it on the power meter. I can't see a dip on the plate current. So I'm telling my neighbor all this as I speak into the microphone. This is probably a common thing that happens with transmitters. Of course, I'm transmitting into a resistor here, so no neighbors hearing any of this. So is that it? Is that the end? Is that the end game right there? So we're left with the voltage at 1.9. The other thing that's concerning me here is when we're just running on the receiver. No, that's a different voltage. No, don't make that mistake. I was going to say there should be something there, but no. Of course, there should be nothing there. The PA is not transmitting anything. I said it was a Class C amplifier. I better read up on that. Remind myself what Class C is. Well, I don't see that I can do anything more with this at this point in terms of this PA, but maybe we'll come back to it, because when you're doing this kind of work, you start out not knowing anything, and all the way along you're learning stuff and discovering things, and there's no reason to think it couldn't occur that you think one thing, do a bunch of stuff, and then learn from that and then realize what you were thinking was not right at all. And you just have to, it's just the way it works. It's the way it goes. That's the fun of it. Just keep telling yourself that. That's the fun of it. So we now have a 2-watt radio here. It should be a 4-watt radio. Well, thanks so much for watching this crazy stuff. Next step. See you on the next video.